Welcome to CommercialDrones.fm, the podcast that explores the commercial drone industry, the people who power it, and the concepts that drive it. I'm your host, Ian Smith. Hey everybody, welcome to Commercial Drones FM. Ian Smith here, and I am sitting at Drone World Expo in San Jose, California. With us is Anil Nanduri, the VP of the New Technology Group and GM of the Drone Group at Intel. So very welcome, big welcome to the podcast, Anil. Thank you so much for joining us.
Thanks, Ian, for having me here.
My pleasure. So Intel has been a company I've really been trying to get on the podcast for a while, so really appreciate the whole cooperation from the company to help make this happen, and of course Drone World Expo for helping us set this up. So before we really get into it, I mean, you guys are doing like a full-blown, full stack of drone technology and autonomous IoT kind of software and everything, but before we get into that and kind of dissecting, if you will, Intel's own ecosystem, I'd like you to tell us a little bit about yourself. So, you know, how did you get in this position, and when did you start the drone group? Like, tell us about how you kind of got here at this drone show and where this kind of came from in Intel.
That's great. I mean, first of all, I think we should talk about Intel as a chip company. What are we doing in drones? I'm sure that's a question on everybody's minds. For me personally, I come from a technology background, engineer, electrical engineer, and did my master's. And I've worked at Intel for over 20 years and started as a chip designer, believe it or not. And then moved towards different aspects of working towards the laptop industry. Not sure if you ever heard of Centrino. It's the first time wireless became very popular.
Of course.
I was part of the core team that enabled that with all the OEM manufacturers like Dell, HP, and all of them who are building those systems. So on a worldwide scale, that was some of the work that my team had done from a technical enabling side. And then moved on to got a good handle on how business works within Intel and moved different roles over time. And as I continued to work and the PC market became more mature, I looked at it and saying, okay, I'd like to try something new. We had this depth sensing cameras called RealSense technology. And that's the group, more like a startup inside Intel. We were trying to get that to be deployed into PCs and tablets. And I was in charge of the market development as well as the marketing for that. And the applications for it thought to be like they can be more than PCs that can use this, and robotics and IoT devices, drones was kind of what started the fascination. Well, where else can we use these? And that's where my interest on drones. To be very honest, I don't come from an aviation background, but being an engineer at heart and curious, was very, very curious on how this worked. Because I flied a model airplane and a model helicopter as a kid, never worked. It was more depressing. You build it all, it took 2 days, and then you try to say, let me put it up in the sky. The first thing it does is crash. And you're like, wait, I spent all this money and I couldn't get it to fly. What did I do wrong? And then when the first time I flew a drone, it's just like, wait, where are the controls? And you just leave it in the air and it just stays there. It's like, wow. It's like, okay, give me a chance to learn. And so I got excited about it. That's how I started with drones. And believe it or not, there's a company, Ascending Technologies, that we partnered with. I literally walked one day in Munich. I was there. I knocked on their door and said, hey, I have this technology called RealSense technology. You guys do drones. Is there something that we could make this work and do collision avoidance?
Is that really the beginning of the story? You just kind of walked up?
Literally, there was an email exchange, but then I just went over to their office in Kraling and said, hey, I would love to chat. And they didn't know why I was there, and they did not know about Intel and depth sensing cameras. But curiously enough, they were looking at sensors and other capabilities that could have, visual perception, visual navigation tools. And when we showed them RealSense, which is like 8 grams in size, they were just blown away. And they said, yeah, definitely we could look at, how this could apply and start playing with it. And that started the history of my engagement with drones. And it also gave me an awareness and curious, okay, so what do you guys do, Ascending? And then started to look at their flight systems. And as we were working on this project, I think a couple of years back at CES was the first time we did drone ping pong. And there's a good backstory there too. When we gave the samples to Ascending, they kind of quickly were able to put it on a drone. We were actually in a conference room at Intel with our CEO playing drone ping pong. And we said, hey, wouldn't this be cool to show it at CES? And we said, yeah, that'd be awesome. And that kind of started that work. And CES was a great hit. And then we had partnered with Unique to bring that to market. But then along the way, learned a lot about the industry, the capabilities of drones. The commercial applications kind of fascinated me, and where this really as a data gathering tool, and the kind of vast amounts of data that needs to be processed, that took my curiosity in different directions.
That's fascinating, really. I mean, seeing how it developed. I mean, and then, of course, Intel eventually acquired Ascending Technologies.
Correct, yes.
And we'll touch on that a little bit later. So at Drone World Expo, are you on a panel, or did you give a presentation, or is that like tomorrow or something?
No, I have a presentation later today.
Okay.
And then I'm also on a panel after that. So those are the two activities. I'm here at Drone World Expo.
Cool. So what are you presenting on here?
Kind of walking through what Intel's been doing. I think it's an important aspect that, as a chip company, you're like, okay, are you giving chips for drones? Well, not really. Here we are actually building solutions. The drone industry being so greenfield in some ways, the opportunities are endless. And so we've looked at it and saying, okay, where can Intel add value, not just in terms of our technology that can help with, but more from an ecosystem enabling, as an ecosystem development. I know historically, if you know, as Intel, we've built ecosystems. And so from a drone standpoint, it's like, how can we bring that experience and see how we can, realize the potential, what drones are, especially in the commercial areas. The other part of it is, ability to evangelize and look at applications of drones. And I don't know if you've seen the light shows we've had. How do you create awareness for broad people? And as we all know, for drones to become mainstream, which this core audience really is passionate about, there is a public perception and acceptance of new technology in society that needs to also happen. And the way you get through that is by showcasing the value, showcasing the applications, showcasing the capabilities, how it can impact them, how they can touch it, how they can feel it. And it's not necessarily by flying a drone. Not everybody is going to fly a drone, but then everybody can see a light show. And so those tend to become, over time, the acceptance criteria for how people see more of these and saying, oh yeah, I've seen a drone, I've seen a light show, now I see it flying near me. And it helps bring that adoption over time, is my belief. And I think there's value in it.
So since Intel is fostering this true like full stack commercial drone ecosystem, to use your words, I mean, it's very commercially focused, but you did just give some color on the whole entertainment drone aspect, which I've been really interested in. And you guys, as far as I'm concerned, own that space. What I imagine is some type of potential consumer product one day where I maybe have like a little app that I download and I get like a very small, I don't know, maybe the size of a ping pong ball or slightly larger, little tiny constellation of drones that I can kind of charge. And then maybe if I'm having a party at my house, I can like upload a little logo on the little app and then be able to have the drones create a little light show that maybe spells out happy birthday or something like that, in my own backyard. And so are you guys, you're very commercially focused. Do you foresee yourself going after recreational or hobbyist uses for like personal drone use? I mean, what is Intel looking as far as that vertical? So
a very interesting use case. And, it comes with, end of the day, we're part of a business and we need to, there's two things. One is the ability to showcase technology. The other part is to make sure that we can monetize and sustain it. And so there's always the business side of the question we have to answer. However cool is the technology? With being at Intel, there's been some fortunate that we have the ability to try these things out, right? Now, as regards to where the light shows scale, you know what? I don't even think I have a crystal ball today where this could go. But use cases like yours have been hallway conversations for us. Is that, can we scale it to that level? What needs to be the price point to kind of be able to get to that? And then what kind of technologies are needed? If you're flying in your house, you don't have GPS. And then if you're flying in your backyard, there's all reflections and other aspects of the outdoor GPS. So can you safely and reliably use it? And then, you may probably want to kind of shrink that into form factors, which may be a lot more in the category of toys. So we have to go look through that. But clearly, from a light show perspective, what we've spent a lot of time on is how do you, not just think about it as flying a drone. Especially all the drones are flown with a computer. It's a touch of a button, so there's no real human being flying it. But how do you operationalize something like this, right? So if you want to kind of use a certain number of drones, how do you first of all create animations? Because the person who's creating the animation, who wants to say, okay, happy birthday, or you want to put a
Wonder Woman
sign, for example, they really don't know how to fly the drones or how the drones behave, but they're creative artists. They know how to go, bring the lights in formations with the music, with the patterns that amaze the audience and visualize the audience. They use tools like Maya or others to actually create those animations.
Oh, wow.
And so the 3D creation process is already mature. So we kind of plug into it and saying, okay, create your thought processes, create your storytelling, and then we have to kind of simulate it so that you can see, okay, how would it look with the drones? So we created this whole software that kind of helps automate that process. Clearly you can't have two light locations in the sky at the same point. Two drones cannot overlap, so you basically have to follow some rules and guidelines in creating this animation. But our software takes care of all of it and tells you, well, if we see a violation of what the drones can do. So kind of automate it. You press a button, you can program the drones, and then you press another button and the drones take off.
Beautiful. I feel somewhat sorry, not very sorry, but somewhat sorry for the person who has to charge and change all the batteries in the hundreds of drones.
You don't necessarily charge or change the batteries, so there's no physical person having to do that.
So it's like inductive charging.
I can't share the details, but you have to think about the operational complexities.
There you go. Okay, cool. Well, I like that little potential tidbit, not a true tidbit. And now, a quick word from our sponsors. Commercial Drones FM is supported by Deveron UAS. Deveron UAS is building a standardized drone network for farmers all across North America, offering on-demand, near-real-time field-level data when you want it. To learn more about how you can achieve scalable data collection in agriculture, visit deveronuas.com. That's deveronuas.com. I'm giddy with excitement to share that I'll be hosting the first official Commercial Drones FM event in San Francisco on November 16th. This inaugural meetup will start off with a panel moderated by me with guests from DJI, Altiscope, and Drone Deploy, and it will start and end with plenty of networking. We're going to discuss opportunities, challenges, and the future of the drone industry. Space is quite limited, so please go RSVP now at commercialdrones.fm/event. Seriously, go RSVP. It's going to be a great event. That's November 16th in San Francisco, and you can RSVP at commercialdrones.fm/event. Hope to see you there. Okay, back to the show. So back to commercial operations and non-entertainment drones. So I'm just going to run down the list of what I know is in the kind of ecosystem of Intel as far as drones go. And we'll start at like the core piece, and that's Movidius. That's like a hardware component. That is like, an acquisition that Intel made.
Yes.
And a lot of drones, a lot of DJI drones have these chips in them, Movidius chips, that are used for computer vision processing and very powerful, chips. that you guys have kind of made, and I wanted to ask you just a little bit about that. I mean, basically on your background of actually designing, silicon chips. Can you tell me a little bit about the whole Movidius thing? And was this one of the earlier acquisitions that Intel made? I mean,
it's a more recent acquisition.
Okay.
And Movidius is a great company. And, if you look at it, what they really have is a machine learning AI accelerator chip. So, you think about, I know people are familiar with what you call as FPGAs, programmable gate arrays. These allow you to program software into chips. That's Altera. That's another one of Intel's acquisition. But then what you tend to do is that, for many applications, you want a smaller chip, you want a lower power chip, and you still want to have programmability, but it's more especially built. And for functions like AI, machine learning, accelerating vision processing. And if people who are more on the technical side of things, when you're doing, say, for example, depth sensing, you kind of use a stereoscopic technique as one example, just like the human eye. So you have two cameras. They're capturing, frames of information. Primarily, it could be 60 frames a second, 120 frames a second, depending on, you have technology that even goes to 40 frames a second these days with the cameras. And you are now looking at it because the distance between the two. You can analyze two pictures taken at the same time from both these cameras, and then you can create depth. You can see it in 3D. And to do that, you have to do this pixel matching and get the whole data analysis done. And that's what RealSense technology foundationally works on. And there's a special chip that does all this processing. Now you can do that with something like Movidius, for example.
And so Movidius could be a component of RealSense to enable RealSense.
You can even accelerate more than things what RealSense do. So RealSense and Movidius together, not only because now RealSense takes care of the depth calculation, you can now use Movidius to accelerate inference. You want to do tracking, because there's so much of compute that needs to happen, and the general CPU or the processors or the GPU that you're familiar with, they take a lot of power and they take a lot of frame rates to actually process this. So having these dedicated accelerators that are programmable, something that's very repeatable, you can do it a lot more efficiently with this chip like Myriad X, which is less than 1 watt of power. And it's super powerful in terms of what it can do. So the flexibility of that programmability, plus the low power nature of it, and then being able to do all this on the edge, that's an amazing set of capabilities. So this is where you're starting to see customers who want to do, hey, I want to look for a crack. How would I be able to detect very fast as the drone's flying, for example? You could actually use something like the Movidius chip on board to create that algorithm that for crack detection. You can actually run it on the drone. The issue is, why is it not being done today? Because we don't know where all the cracks are. What is the definition of a crack? But once that's all well established, these chips can do wonders.
Building the training data and such. Okay. Very cool. So the next thing was going to be RealSense, but I mean, that's kind of covered. I mean, that's how, from what I understand, you take... is RealSense more like a kind of like a software, like a system level software then? It has less to do, like you can buy like a RealSense unit, if I'm not mistaken.
Yes, you can buy one.
But it's kind of like it's the software layer that goes on top of the hardware.
There's two pieces to that. The hardware itself, what RealSense gives you is you plug it in, it's a USB interface, and you really get complete 3D data. So you see images in 3D. So you get the two cameras. It's a stereoscopic camera, and there are multiple versions of RealSense, by the way. One example here is this stereoscopic camera I'm talking about, and you're able to then look at the image in front of you. You get the 3D processed data. So you're getting a live feed from the cameras processed through a chip. You can see the whole thing in a depth map. When we say a depth map, is that you're seeing an object. So today, when you take a picture with a camera, it doesn't tell you how far it is from you. Right? What these RealSense cameras do is that you get a voxel. So basically, you are getting a pixel, but you also know how far it is from you. That's what we say is 3D. That data is amazingly valuable, especially if you're in drones when you're flying. And as we look at more automation coming in and drones becoming more autonomous, then you have to work around obstacles. You have to work around trees. You may not know that there was suddenly a crane at a construction site, but the drone should be smart enough to know that and navigate around it. So that's what these sensors do. The other way of some people are doing is, okay, rather than using RealSense, you can then actually physically put cameras and then use something like a Movidius chip and then use it to do this processing. So RealSense just helps you make it do it faster.
And so those two, the kind of the hardware component being Movidius and then the RealSense system level software and algorithms and whatnot. I mean, those are like Intel's traditional kind of like specialties. So then we go into finally in the ecosystem of Intel, the hardware platforms. This is where everyone is probably like wondering what's going on here. You've got Ascending Technologies, a German multirotor manufacturer that's been in the game for years. Mavinci, a German fixed-wing manufacturer that you also acquired. And then you've created the Shooting Star, which is the entertainment drones. And then the Aero platform, the Intel Aero platform, which is targeted more at developers.
Correct.
So what is the deal here? I mean, we talked earlier about, but why create this ecosystem? I mean, where does Intel, I guess, see itself in 10 years with this entire like stack? And not even mentioning yet, the next item we'll talk about is Intel Insight, the new software that was announced. But maybe you can just talk a little about like, okay, we've got a fixed wing, we've got a multirotor, we've got a small multirotor, and we've got a developer multirotor.
So, I mean, this is a good question. And we are in a new world. In the past, typically the way industries worked was that you come up with an idea, especially in a new industry, you create a standard, you wait for the standard to mature, and then you kind of work towards deploying it, and then you take your years to, slowly bring that technology. And you look at how Wi-Fi came into the, mainstream. I mean, these are decades of work that went into it, right? And creating the 802.11 standards, and you standardize it, and then you work towards the standards. The other part, what we're seeing more and more is that, people are looking and saying, all that's great, technology is great. What can it do for me? Right? So show me the results. If the technology is the way to do it, and I want to see the results faster. And so it's becoming more solution centric. And the other part of it is that, to build that and prove it out, like Lightshow is a great example. I could probably don't conceive of a way where I could put this in PowerPoint and go tell FAA, hey, give me permission to fly, because here's a great little technology that I can explain to you, and I will go develop it. And so they're like, no, come when you're ready, because I want to see it and I want to know it's safe. And so we had to actually build a whole system to kind of showcase that this can be done. And as regards to the commercial platforms, and that's why Shooting Star was a solution thinking, because we knew that if you flew the 50 drones and just take them off the shelf and try to build it together, at some point the complexity of managing it, you talked about charging the batteries as one little example, programming them each one, because each of them have their own little SD card for flight management, or you want to talk about hey, how many people do I need on the ground to actually put them all together, line them up, it starts to not become a way you can scale it, right? So we had to think of Shooting Star as a system, and we thought of it as one thing: make a brilliant light show. So it had 4 billion light combinations. So it was thought with the end in mind. So it's like, hey, the people who are animators, they're like, okay, help me make it animate. I don't really care how you do it. And that's our job. And so we had to build that solution. On the commercial platforms, we saw that Ascending, as well as Mavinci, had some really compelling systems, and we saw the value that they bring about redundancy. The multirotor system with the Falcon 8 Plus, it was
multiple autopilots on board,
and very, very safe. And then it's a platform approach where you can swap payloads, and you have adaptation to magnetic interference, for example. It had triple redundant IMU. It had extra rotors for redundancy as well. A very high payload to takeoff ratio. Very, very accurate precision platform. And, we saw an opportunity that, hey, we could scale this and scale these technologies and make them better. And that's exactly what we're doing is, when you have assets like these, why not stretch our imagination and look at what problem we are trying to solve here. And this is, I think, the key is that even the drone itself is a data acquisition device. There's going to be, the drones are getting smarter, which means you need more onboard processing. So eventually I see a future where chips like Movidius, communication links on the drone, and, completely controlled by computers, being able to, inspect hard to reach places, places where it's sometimes not safe for us to go, infrastructure, and to give us that information real time. That would be one aspect. But to get there, you need a lot of data gathering, do the training that we talked about earlier. You need to process gigabytes and terabytes of data in the cloud so that we can learn from it. And so if you think of the tool chain, one is how do I automate and repeat, on a consistent basis, capturing of this information, and it's accurate, right? Whether I need no more ground markers, no ground control points, how can I use RTK technology and do it without having to, have a expensive manual setup process of GCPs or other things like that? How can I do that? And then leverage data both from multirotor and fixed wing, ingest all this information so that I can repeat it, and then start to look at, analyzing it. Because even if I gave you 10,000 images, Ian, you're going to what do I do with it? You get bored. So even if you're sitting in an air-conditioned back office, you don't have to be at the site, but then, you can analyze this humanly. And we already know that tools exist today, except that the, machine learning tools are more looking at, families and our friends and, spouses' pictures, or who's smiling, who's not, what are my pets, but we are now trying to apply it to inspection data.
Yeah, and this brings us to Intel Insight. So this is really interesting. So this is one of the most recent announcements that Intel has made, if I'm not mistaken. So a little bit of background here. So my alma mater, Delaire Tech, who's now known as Delaire, partnered with Intel, and in partnership have built a software platform to take all this data that these drones are collecting, that are powered by RealSense, powered by Movidius. I mean, you're seeing the full ecosystem here, and then start to make value out of it. So tell us just a little bit about the Insight platform. I mean, I've seen, so the CEO of Intel, Brian Krzanich, announced this on stage at the Interdrone event. And then I actually saw this with my own two eyes at Interdrone in Berlin just the other week. And it looks really impressive. I mean, seriously, really nice stuff. And so, where do you see this going? I mean, with as far as the software goes, I mean, it's still kind of early days. There's lots of work to do, obviously. But tell us a little bit about some of the cool things that you guys are trying to kind of do that maybe others aren't really being so effective at today.
No, again, like I said, there's a lot of innovation going on in the ecosystem. And we at Intel have taken an approach that, you don't have to build everything. There are good partners out there. And definitely the idea here is, can we all scale this ecosystem? If you look at the opportunity of drones, it's huge. Now, it's not going to be one by one player or two players. I think there's enough differentiation and capabilities that are needed that it'll take the ecosystem to achieve those objectives. How can we accelerate that? Intel Insight is a great solution from processing all this data that comes from drones. And we're typically looking at, a standard first step of processing is photogrammetry. And this is where, we've had not just partnerships with Pix4D, Bentley context capture. So giving the flexibility to the users that they're most familiar with in being able to handle this. So this is a cloud-based analytics platform. But the focus is now then saying, getting the standard set of drone data, being able to annotate it, being able to get, a DSM model, or you want to get a, auto mosaic. These are standard tools tools that this platform will support. But more interestingly is then to start saying, hey, how can I create automation of analytics? One interesting example, and we showcased that, was a concept of change detection. At Interdrone, we flew live across a facade that we created, to showcase the capability. And we said, okay, now how can I have 2 flights? And we intentionally made some changes in the facade and said 2 flights and say, okay, throw it into the computer. How can the server now tell us, okay, what changed? So that I don't have to go through this painful exercise. I think there were like 200 odd images to compare to.
Love it.
Right. And so it basically walked us through, like, okay, here are the 4 or 5 changes we see from automated.
From one data set to the next.
And then it kind of highlighted that in a very simple to understand, you could do it side by side, you could do it as an overlay, and leave it to the flexibility to the user, and said, okay, here's how I see these different changes. And you're able to then look at it and saying, okay, now it needs additional attention. Over time, I expect not only we could do these comparisons, it can predict, it can even recommend, and it can also send it off to the right maintenance person who needs to go look at it. And the value of something like this is phenomenal. And then the knowledge that the systems gain then can then be used for training. And then you can actually train the drone itself. Why do I even need to process this data? Can the drone itself do this? And I think that'll be in
real time.
Yeah, it'll take time. This is where the future will be.
But I mean, I think, and sorry to interrupt you, but like eventually, if the drone's going to be doing it in real time, eventually it's just going to be like, all right, stick a screwdriver on the drone. Maybe the drone can just like screw it and fix it. And so a person doesn't have to go up there and they can spend time, doing something else. I mean, that's a potential route forward for this too, as well, right? That's,
I would say, still, having the stability of a drone to be a real time in the air robot, if you must call it. Hopefully, maybe,
if anyone can do it, it's Intel.
I wouldn't say that, but I think there's a lot more physics that have to be met to have that precision. And like I said, end of the day, the maintenance worker, for example, or the maintenance crew that needs to look at it, they look at it, is that the most cost-effective way? If the economics work, I totally believe technologies like these will get invented. Or even, I would say it's more evolving the technology. I don't think it's as much as an invention. And one of the examples, like in Japan, for example, the human capital, I mean, even if you wanted to do it with people, the aging population, you'll be amazed that, they don't have the infrastructure of human capital to go do these inspections, let alone then the maintenance aspects of it. So there is a real necessity of automation and of allowing these systems to do it. And I still believe it all has to be done safely. And it all has to be with what I call human on the loop, which we would like to say, which means that there's always the ability for us to step in and provide that, control about these capabilities and tools and oversee it, because there's still a lot of knowledge that we people have that these machines can't replace.
Absolutely. So all of this plays a role. I mean, the whole ecosystem here. So what are some things that we might see next from Intel? I mean, what general direction are you heading? Like, what are you kind of focusing on, and like, what's like the imperative mission that you kind of have? I don't know, maybe over the next few years or something.
So, we have a great team at Intel, very passionate team. And like you said, some of them are pioneers in the drone industry, and their dreams are, and my job here, not just to fuel their dreams, but at the same time, realize them. I don't know if you know about this. There's a man-carrying drone called Volocopter.
Yes.
And it's the same
Another German company.
But the flight control technology that powers that Volocopter, as well as the rotor electronics, is actually generated by our team at Intel. And so it's, again, the scalability of the technologies we build is very applicable in different areas. At AUVSI Exponential, we actually, we talked about, having a drone. We built a bridge to do an automated inspection. But along with that, we also did a light show with about 10 drones inside the conference area. There was no GPS GPS. So you talked about your little vision of having your little,
my own personal light show.
Yes,
it's a very selfish.
Yeah. But to do that effectively, you need to have some reliable positioning technology that's outside of GPS. And what we really demonstrated for some people is that, it was a great show, but how did we do it? We had to have some, technology there that we could fly with precision indoors. So, there are tools like these, which, we see the potential, and we're going to continue to develop those. And we also do a lot of open source activity. So we have the Aero platform where we have a computer on board. So it's not just us working with the Movidius chip. Someone can plug in a Movidius chip on the Intel Aero platform and develop on their own. So, we and it's a full open source platform, supports, Pix4 flight controller stack, Ardu Pilot flight controller stack. Today it's on Linux platform. It supports the ROS interface. So it's again, for people wanting to build applications, the Aero platform is great. And we just, it's open source in that regard. It even has supports for RealSense cameras. So it's up to their imagination. Now, we don't see this as being a commercial drone, for example, but it's more as a test bed. One great example was we were working on UTM testing. Now, I don't know how familiar people are here, but that's the NASA's efforts to create air traffic management system for unmanned vehicles. And so it's unmanned traffic management. And to test it, you have a server that's managing the clients, which each of it is a drone. Now, with the Aero platform, the implementations are very different. So AirMap has their version of UTM. Google has their version of UTM. But guess what? Within a day, both of them could actually configure an Aero platform, because it's fully open source, to be their client and to test it. We did a TCL2 testing at Virginia along with Google and NASA. And then AirMap did a testing in Switzerland recently using the Aero as another client. So, it becomes a versatile tool to go be able to test these kinds of capabilities. Again, this is not the final commercial drone that may implement it, but to get your software more robust, it's a great vehicle.
Wow. So we have literally gone through the entire gamut of a possible involvement almost in like every aspect of the drone industry. So that was very eye-opening. I mean, I definitely could have asked a lot more questions, but we'll cut it short here in order to leave something to the imagination for everyone listening. If everyone listening, you can follow Anil Nanduri on Twitter at Nanduri_Anil. That's NANDURI_Anil. And you can visit Intel's drone website to see all of the stuff that we talked about at intel.com/drones. So before we cut off the mics, do you have any last thoughts, Anil, to impart the listeners with before we're done here?
I mean, you always knew Intel as Intel Inside in your PCs and computers that you used, but with drones, we're actually Intel on the outside. You can buy them, customers can use them. So we are selling commercial platforms. There are customers who want light shows. We service and do a service of light shows for them. If you want to be a developer and want to use our platforms, we have access to that. So it's not just we are building technology here, we are building products and solutions. And of course, the Intel Insights platforms, which will, we haven't announced the release date yet, but that'll help automate a lot of the drone data processing as well.
Great work. Well, keep it up, guys, everyone on the Intel team. And so while you're at it, if you want to follow the podcast on Twitter, we're at Drones Podcast, and on Facebook.com/Drones Podcast. If you want to support the podcast, head to Patreon.com/Drones Podcast. And just for $1 a month, you can get access to the private Facebook group, who all previous podcast guests get an invite to. So if Anil wants to join after we air his episode, then he might be in there and then chatting with like-minded folks about commercial drones and the industry. So thank you so much for listening, everybody. We'll be back in a couple weeks with another episode.
Thanks, Ian.
Cheers.